This project is the chiller plant expansion for the high-performance computing facility. The owner of this project is the University of Texas at Austin, and the main contractor is DPR Construction. The location of this project is 10,100 Burnett Road, Austin, Texas. The project consists of an expansion of the computing facility, but this Naviswork model will only cover the chiller plant expansion. The project layout is as follows. Outlined in red is the chiller plant expansion. Outlined in blue is the ingress and egress of the project. The outlined in black is the site laydown area, and outlined in orange is the job trailer area. Now here's a quick overview of the chiller plant expansion model. I will show the construction sequence later in the presentation. The first part of the construction process is the substructure. Here we see the first sequence of piers poured at the main building. We also see the start of the excavation for the main building grade beams, along with the start of the piers on the cooling tower slab at the top of the screen. Now we see the grade beams for the main building have been placed. Also, the formwork for the 8-inch slab of the main building is being built. Now the piers for the cooling tower slab have been poured. During that process, the excavation of the yard piers has started on the right side of the screen, along with the grade beams for the cooling tower at the top of the screen. Also note that the 12-inch slab at the cooling tower is being formed at the top of the screen, along with the entire 6-inch slab for the main building. Now we can see that the 8-inch slab has been poured in the main building. Also, at the yard on the right side of the screen, the piers have been poured. The 12-inch slab at the cooling tower slab has had it been poured along with the grade beams at the top of your screen. Lastly, the grade beams are placed in the yard on the right side of your screen, and the 6-inch slab is poured for the main building in the cooling tower. Next in the construction sequence is the structural steel. First, we see that the structural columns are placed on the cooling tower slab in order to support the cooling tower. Also note that the structural columns are being placed right to left for the main building. Now all of the structural columns have been placed in the main building. Also note that the horizontal structural beams have been placed on the cooling tower slab to permanently support the cooling tower. The next step in the construction sequence is the superstructure. The first step with the superstructure is building up the CMU walls for the main building. We see here the south CMU wall being built. Now we can see that the east CMU wall is being built. During that time, the brick, doors, and louver windows are being placed in the south side of the building. The north side CMU wall has now been constructed. The overhead doors and regular doors are placed while the west side CMU is being constructed. The shorter CMU walls in the yard have now been constructed. Also note that the main building CMU walls are now covered in brick. On the interior of the main building, the full height interior CMU wall is built. Also, in the interior of the building, horizontal beams are being placed to support the structural beam system. Finally, structural beams facing north to south are placed to permanently support the building. To complete the superstructure, the roof is placed in to provide permanent cover for the interior of the building. Next is the electrical roughing. The Naviswork model for this is provided by DPR. Therefore, for all the MEP, the model will be placed into my model, and we will examine the elements of each division of work. Note the electrical units placed in the yard along with the conduits underground going to and from the building. These supply the building with its power. From the interior view, we can see the overhead lights hanging from the ceiling, mounted wall fixture lights, along with electrical boxes lining the interior CMU wall. Lastly, we move into the main mechanical room, which consists of hanging and wall-mounted lights. Also note the electrical connections on the floor that will later connect to the mechanical and plumbing units placed later in this presentation. Next is the plumbing and mechanical roughing. On the exterior, the cooling tower is placed on the structural beams installed earlier in this presentation. Also note the piping coming out of the east walls. These pipes will supply the water that will cool the computers on the other side of the construction site. Also, 4 roof units are placed for air conditioning and ventilation of the building. The first thing we can see are very large mechanical and plumbing fixtures placed in the building. These are all connected to the main computing facility in order to properly cool the vast amount of technology used there. Lastly, now we can see a ventilation duct in the building that provides the building with its cool air. Thank you for watching my presentation of the chiller plant expansion at the High Performance Facility in Austin. My contact information is listed below if you wish to contact me. Thank you.